Share screen. Screen 1. Share. Okay. All right. Now that we got this started, we're looking at factorial code here, and when we run this, we can set gives you a total number of steps. So you can see what's happening is it's giving you the variables and their type. So I've got two variables, one called res, one called base, and it tells you what they are, and it tells you an init. And then as you go through this step, you can see which ones get changed. Now, if you're a beginning programmer and you think like this, you think visually what's happening to blocks of memory, that's the way I think. I won't say it's the only way to think, but it came that way to me naturally because of the way I learned how to program, which was assembler first. I don't recommend that for most mortals. Okay. So you can walk through the code and play with it. And we have this thing called the stack, and we keep putting stuff on the stack. And then boom, it's done. And it tells you what the final answer is. Okay. This is a handy way to check and visualize, like next semester, 272, you're going to have to write stacks and queues. Well, what's a queue? Well, a print queue, or standing in line in a queue. Here's a piece of queue. There is a whole branch of mathematics called queuing theory. How do you get things in and out fast? You know, Amazon has people working on this. And when they have a warehouse, they bring new stuff in. It does not go anywhere special. Let's say somebody orders a safe for their valuables, big old monster safe. They put it in the warehouse wherever it fits. And then they scan it because their scanners have GPS built in. So when they look for that item, the computer tells them where it is and they go get it. When I was working in field service, we had bins of parts, and these parts were always in the same place. So when a new shipment came in, you always put them in the same place. Labor intensive. So when you just take something and throw it wherever, scan it, you know where it is, not so labor intensive. Queuing. One question, printers. Printers can take up to 2,500 simultaneous print jobs at the same time. So everybody in this room could print 10 jobs immediately to the printer and it wouldn't die. Which print job gets printed first? Short ones or long ones? Given all things equal, they all came at the same exact time. Which ones print first? Pardon?
Short ones.
Yeah, big ones or little ones? Little ones. Everybody said little ones. Actually, it's reverse. Big ones get printed first because each print job has overhead and timing. So the big print jobs print first because overall, you can print faster and get done sooner if you print the big ones first. Okay. Sometimes that's the same way of doing homework or taking a test. You know, that I find I take a couple, read through the whole test, find the easiest answers to build my confidence, and then go back and work on them progressively. Okay. So this is off the main website. You can play with this. It doesn't work with assembler. If you find one that does, let me know. Okay. And let's see. In the world of stacks, I want to show you this. a stack-based machine is what you're doing when you surf the web. When you have Google running or Firefox or whatever, JavaScript gets processed and it does stuff. The things that happen are in a stack-based machine. It's a virtual machine that lives in your browser. So when you debug it, oftentimes you have to get into the browser itself and see what's happening, okay? So this JavaScript and WebAssembly coming to a future near you, there is an intermediate value when you compile to it. Like we have save temps, right? Anybody see what those files are? There's a .i, a .s, a .o, right? They all mean something when it gets compiled. WebAssembly does the same thing. You can take Rust and compile it to WebAssembly. You can take Go and compile to WebAssembly. You can take Swift and compile to WebAssembly. So it's going to become a thing, okay?
Quick question to temp files. I got a good idea about what .o and .s are. What is the .i?
The .i intermediate is what that stands for, is that that's the first pass the compiler takes. So it takes the human readable code and it does labeling for the next pass. Back in the day, there was a difference between single pass compilers and multi-pass compilers, and single pass ran faster, but it created sloppier code. And over time, that argument says we can't do this anymore because our infrastructure, we can't write sloppy assembler. We need to tighten it up. So most of your compiles now are multiple pass compiles, okay? And this is an example of this stack of what it looks like. Now, that's what it looks like. You're going, why do I need to know this? I'll show you, okay? You probably won't need to know it specifically, but it will come in handy to add to your trivia hopper for those interview questions, okay? Remember this, JavaScript is nothing more than a scheme interpreter with curly brace notation. I've mentioned this before briefly. What is scheme? It's a programming language based, it's a derivative of Lisp that is been around since the dawn of man. The dawn of computing. And if you go to 99 bottles of beer on the wall, and I'll bring up scheme and show it to you. But there's also other languages that fit inside of this. Guile is another one. If you jump the fence from Vim to Emacs, you can extend Emacs with a programming language called Guile. Okay, but I want to look at scheme and show you what it looks like. Let's see. Scheme. That's scheme. When you do math in scheme, you would write it like this. You're going to say times 8 times 7. It's called reverse Polish notation. This is how you put data into your stack. So the way this works, you go this way. You put 7 here. In comes the 8. 8 goes there, 7 goes there. In comes the multiply. Then we put multiply 8 and 7, and then the next command we send says multiply the two together, it pops all of them off the stack into the registers that you're kind of looking at in your assembler in the Xi books. And it returns the value back to your register. And then you can do something with it. That's a stack machine. Okay. And you don't really program at that level, but knowing what the syntax is, this syntax is very similar to WebAssembly Intermediate for that. They call it the text mode format. What do they call it? The text format. Okay. And you can flip a switch and look at it and debug it. And your hello world creates like 9 million lines of code. I mean, it's crazy. Okay. All right. One more in this space. This guy, Godbolt, is, I don't know who he works for, but whoever he works for pays him to develop this site. You put your code in, pick your language, obviously. It even does assembler. Okay. But what's nice about the assembler part is it doesn't tell you really anything more than just what we do in class. Okay. But where this really comes in handy is other languages. For example, let's take D. This is a programming language called D, and then you can change the output to use the ASM syntax, the Intel specific, or not. I am biased towards using the GAS syntax or the AT&T syntax because it is agnostic as far as what chip you put it to. Okay. So you don't have to have a specific type of assembler. You just write it and you compile it for that machine. Okay. We will talk about cross compiling in this class, and I will demo it, but I probably won't have you do it. Okay. Just so you can see what it is and understand what cross compiling does. Like, how do I write code for a Raspberry Pi on my Intel box? How do we do that? Well, that's just it's a compiler switch. You just change it and boom, off it goes. Okay. So notice the output is still our assembler. We can choose our outputs in any way we want to look at it, and so on and so forth. So this is a way to look at programming languages. Anybody heard of Dart? That's a Google programming language, and they use it for their front end stuff. It's pure object oriented, and Kotlin is another one they use. And what I'm noticing in the big companies, they're doing the same thing that automotive manufacturers did years and years ago, called vendor lock-in the sneaky way. When I'm a mechanic and I'm working on Volvos, I need tools that are specific to Volvo. I can take all my tools and all my knowledge and go to work on a VW, and I'm going to have to buy a bunch of new tools to work on that VW. Okay. This is what's happening in the world of programming. You want Objective-C, you're going to be working for Apple, and you become the top guru in Objective-C. They lay you off. Now what? You got to go build up your knowledge base on another programming language. So just get used to it, because you will probably get laid off in your career. Okay. It's just going to happen.
Python, Java, C++.
That's Ed Walsh's recommendation, and I will go with him because of all the programmers I've known over the years. He's the second one that actually I know who gets to write greenfield projects, i.e. here's your spec and there's no code. Everybody else I know in the industry, works on brown field, stuff that's already written, and it's got to change it to do something else. Okay. So yeah, learn those. Or there's a new push from NSA basically, and it's also highly recommended by Google, Facebook, Apple, Microsoft, AWS, is start learning languages that are memory safe. What is that? Anything but C and C++ is what they're saying. Java, Rust, Go, Swift, all those languages are memory safe. Okay, so if you get really good at, here's the way I would approach it. Pick your language, I don't care what it is. Get really good at it. Get good at that one language. Then pick up another one. Because if you try to learn 5 of them at the same time, you're going to get about to the same level of all, and you're not going to be very good in any of them. You're going to be an advanced beginner in all of them. Okay, so pick one and get good at it.
Jack of all trades, master of none.
Yeah, very much that way. But in reality, that's life. When you're doing production coding, it depends on where you're working and what level of the stack you're working on. Are you going to be database stuff? Or are you going to be doing front end stuff? So JavaScript is one that it's a love-hate. Everybody, you know, it's not the top favorite programming languages, but Microsoft did a good thing with TypeScript. They made JavaScript a little more robust so it doesn't fall apart all over itself. Okay. All right, so back to doing our homework. So there's that. This is where the C is, and then this is the header file. Now, notice how I did the guard file, okay? This is not right or wrong. This is just another way to do it. Another way to do this is this way. Is my 2. I use 1 guard. That works fine. No points, no harm, no foul. Here's why would I do one versus the other? If it was long term and I knew this was going to be something I'd use these many locations, I would do it this way to make sure that I have my libraries that I move from company to company that I use to make my job faster. You'll all have shortcuts that you'll create that you will take from company to company. That's how I got my big raises. I took my little cheat, this first thing. EMP, okay? Cat minus greater than. Gave me raises in all my jobs. What's it do? Redirects input to output. Print to email, print to disk. That's all it did. And it gave me huge raises. This is the problem I was trying to solve in the first company is that they had a printer subsystem and they wanted to print to a physical printer. And I said, I don't want a physical printer. I want it to go to email. And they said, it can't be done. I said, wait a minute. When you tell somebody who's curious that it can't be done, guess what? You figure out a way. I figured out a way. Now, this first time I figured this out was really hard. It literally took several weeks because I had to peel back the spooler subsystem on that particular database and see how it worked. That took a lot of time reverse engineering this crappy spooler system. But once I figured it out, it was very easy. It was just a shell script. When I got hired at Foster's, they were doing the same stupid thing. They had the same database and they were printing to hard copy, taking the hard copy, bringing it to the desk and typing it in Excel. All over the company. That was the only way they were taking data from point A to point B. So I used the same exact technique, got a nice raise. So that went with me everywhere I went as I changed jobs and different job descriptions. Okay. So you too will develop libraries, shortcuts, Vim RC files, aliases to make your life easier. Okay. All right. Now I do need to mention the standard in, standard error, standard out. Has anybody seen it? Have you seen it in the ZY books? The lineage class, that makes sense. It should be there. Yeah, it's definitely in the lineage class. And you've seen it from error messages. That's right. Now, this concept, standard in, standard out, standard error, is on every operating system. Okay. And I'm going to demo it simply on a, let's see here. Let's make this bigger so you in the back can see it. Let me hit the right button again. And change directory, clear this. That's a little too big. Now, the way they're labeled is, this is standard in, standard out, standard error. Okay, so we have 0, 1, 2. You know those argv, argc things that you've been passing back through in the command line? This is the same kind of thing. It's used everywhere. And when we create a file, so if I take that and do cat minus greater than $temp, $$ is a shortcut for give me a current process ID when I'm creating a temp file. I hit enter. What's it doing? It's taking standard in and I'm redirecting to file. What's standard in? Your keyboard. Input, some kind of input goes here. Okay. So enter some kind of input. Okay. And hit enter, backspace, space, enter, and then Control C. And notice there's my file. That's the process ID I used. Now I can use cat, which just says display it. Notice the backspaces went away. You know, you don't see backspaces in here. Okay. That is standard in. Standard out is what cat defaults to display the contents of the file. And then standard error is what you get when you have a error code when you type something in wrong. So if I say, how about GCC gives me an error. Now, let's take that same error and redirect it to a file. Which one is standard error? 2.
If it was 1, you don't have to specify because that's the default.
Yeah. Oftentimes you don't have to specify. You can specify if you want. Now, the same concept works on Windows. MS-DOS. It goes way, way back to the days of CP/M even. So this concept has been around a long time. So if I do LR, which is my alias, one of my aliases, if I say alias LR, you can see it does that flatter. So LR, which basically says, give me a list long, all files by time, reverse order, last one, newest. Okay. Where'd my, oh, I've got the same ID. Okay. Cat 25. There's my information. So I redirected standard error to a file. This concept of redirection and taking files, output, input, how do I get data into a box? How do I get data out of a box? Is where you will spend a lot of your time. I don't care what you do in programming, you are going to be moving stuff between machine A and machine B. That's what I'm going to show you next. Okay. This is the kind of stuff that helps you keep your job. Okay. You know, I can give you a lot of stuff to help you get the job, but there's also a lot of stuff you need to keep the job. Okay. So on the machines in front of you, log into your guest and open a command line. And I'm going to do this on Windows just to give you a demo of what it looks like. It won't matter. Okay. All right. So get a command line. Now, here's what we're going to do. Big picture. We are going to create a file on your local machine in front of you. I'm going to show you one of many tools to take that file and put it on the Jeremy box. And then I will show you on the Jeremy box how to take that same file off and put it somewhere else. Okay. So let's start. I'm going to say cat minus. Oh, wait a minute. I'm on MS-DOS. It's all different. I have to do something like this. Pipe to console to, I'll call it junk.txt. Whoops. Copy. Con. I don't use DOS very often. This is the way you do standard in on MS-DOS. Okay. So what you'll type in, let me open a shell over here. And this is a different box. That's okay. But I can make it bigger, I think. Maybe not. Oh, I know. Let's do this. Just a second. Let me open a terminal. Here we go. All right. I'll do it the same as you're doing it, except slightly different. I'm on my box in my office, so same difference. What you'll be doing is the following. And the command line. Type in cat minus redirect standard in to standard out and give it $.txt this time. So it has a file, and then type in your name and whatever you want to type. Hello world. And then Control C. Control D. Yeah.
What's the minus sign for?
The minus sign, that is redirecting my standard in keyboard to standard out.
Those greater than less than.
getting there. In the Linux class, they go over all this stuff. And managing all your cloud services, you're going to need to know the shell. Sorry, you're going to need to know the Linux shell because that's how the cloud runs. And PowerShell you can now put on Ubuntu, and PowerShell and Bash are starting to get closer and closer together. Okay, so now let's just cat that file. LR, there it is, it's 48. So I now have this file. I want this file on the Jeremy box. How do I put it there? Well, there's a gazillion tools in this space. I mean, literally a gazillion tools. You can use Netcat, you can use Z-modem, Y-modem, well, Z-modem is still, you can still use that one. I'm going to show you something called SFTP, okay, because I find it to be the most useful. And then there's scopy, and let's see, and then one of my favorites is SSHFS. That means take the mount point from the Jeremy box and put it on my machine here locally in front of me. So I can take my home directory, the one you go to on the Jeremy box, and mount it to the box in front of you. Anything you put in that directory, automatically in the Jeremy box, using SSHFS. Not very fast, but it works great.
SCP is faster than
Which one?
SCP.
Oh, fast is a relative term. I would say SCP is faster if you know what exactly you're going to copy.
You have to know exactly where it is.
Yeah, you need to know where it is and where you get it. It works great. I use it, but my problem is I'm almost always moving more than one file. So SFTP allows you to move them all, which makes my life easier. Okay. So let's show you how to do this. So I want to use SFTP to move this file to my machine, my directory on the Jeremy box. Okay. Type in SFTP. And then all I do now is I use the same type of credentials that I use for SSH. Okay, when you log in from the command line. So I give it this, and I give it the name of the machine, jmkll.org. And what this is doing is it's taking FTP, which is an old program. It's been around a long time. It was around even before SSH was. And what they did is they just made it secure by wrapping it in the SSH protocol. So you type that in and then boom, it connects. But in your case, it's going to prompt for something. What's it going to prompt for? Your password. So you have to use your name, not mine. Okay. So use your name, your login. How many, other than Gabriel, how many have used this in the past? Couple of you. Okay, well, that's good. All right, SFTP. So I'm now connected. Where? Okay, I'm connected to Jeremy box, but where? There's commands we use to find out where we are.
Well, you can just LS.
Right. There's two LSs. There's LS and then there's LLS. What's the difference? LS is Jeremy. LLS is local LS, the machine I'm on. So when we take our files, we use two commands and they're called get and put. Where do we get and put from? It's in reference to a local. Okay. So when I'm on my machine and I connect remotely, I put a file on remote and I get a file on remote. Okay. So I want to put that one file, this one here, 4.8, whatever it was. So I type in put 4.8, and then you can use tab expansion. In other words, you type it so it's unique enough and hit tab key and boom, it saves you a few keystrokes. Okay. Now what this does is it puts that file on the Jeremy box in my default home directory. Okay. So let's take a look at where that is. So if I type in ls, which is where? In front of me or on the Jeremy box? It's on the Jeremy box. So I'm going to say 4-star. There it is. Now, if I do it locally, I want to do LL, right? So it's LLS 4-star. There it is. Okay. So now that I've pushed it over there, let's use our tools that we already know. This guy. And I want to go to my home directory on the Jeremy box. Scroll down. Oh, looky there. There it is. Bingo. Poof. All right. Now, the reason I use the Jupyter Notebook, 2, 3, 4 reasons. One, the biggest reason is all I have you do is terminal connected, browser, all you need. I do not have to teach you what you really need to know, which is how to connect from anywhere, Windows or otherwise. SSH. Now, not only do I have to teach you how to connect, I need to teach you how to find your stuff. Because most of you don't know where it is on the command line. Like on your Windows box, you save a file, where is it? Well, most of the time you know. And if you don't, you can search for it and you may find it. And then again, you may not. Because if you bring it up as an attachment in email and hit save, it puts it into a hidden directory on Windows and you won't find it. Okay. Which is a headache inducing problem. Okay. So finding where you are, we use some basic survival skills, PWD or CWD. CWD is DOS, does the same thing. Print working directory. Where am I? Okay. And then LS says, what's there? And you all the flags to LF. Okay. And then cat. Okay. Cat shows you what's in it. Okay. So if I want to do LS, one of mine is this L, but I don't know what's a directory or not, and I'm lazy, I can use this uppercase F. And notice I'll put the little slashes on there. It now tells me that those are directories. So I can also look at this over here. That's a directory. But visually, I'm looking at the file name. Okay. So SFTP, we put the file. Now, how do we get it?
So is the line of like permissions or attributes?
Attributes is what they call it in Windows, and permissions is what they call it in Linux. They are functionally equivalent. In Windows, you have more attributes. On Linux, you don't have as many.
The reason why I pull that up in Linux class, I want to list them, list attributes. But
LS.
Uh-huh. Yeah, it's just a term. The attributes of the file, is it executable or not? You know, there's different ways to display it. Okay, like when I display, what happened to my screen? All right, we'll go here. Make it bigger. So I can display it many different ways. And it's just do man space ls and look at all the switches, pick your favorite and run with it. Okay. All right. Now that I've gotten my file pushed. Okay. How do I get it? Well, let's do this first. Let's go over here, look at the file, and I'm going to add another line. Okay. Okay. That's the problem. Let's say hello. All right, we'll do that. So I'm changing my file. Okay, no big deal. File saved. So it's saved. Okay. And for the grins and giggles, I'm going to close it. And I am on this one. Which one is it? Wait a minute. I was on the Jeremy box, right? Or was I? Where did I change the file? Oops, I was on the wrong machine. This will happen. You will have to acknowledge the, you will have to know where you are, because I'm working on my code, I'm going to push it to a machine. I'm working on my code. I just overwrote what's on my machine. Oh, nuts. It's going to happen. Okay. So let's see how we get a file. Okay. And my DOS went. So I'll go back to this one here. So let me exit out. So I'm going to get a different file. Let's say I want to get some other file. So I'll do my ls. And what you will find is that when you have the SFTP prompt, ls doesn't have all its options. It only has some. Okay. So let's see here. Let's take that notes file. I'm going to say get 20. Okay. 202. So I've now pulled from the Jeremy box that file to sys76z, which is in my office. Okay. So I can type in exit, do my LR, see the very last file, and I can cat this file. All that, isn't that fun? Isn't this great? You're going, I'll never need this. You're right. You may not. But then again, you may. Okay. Especially if you're in a heterogeneous environment, you're going to need to know this. Okay. So I'm just going to exit this out. Now, the other reason I have you use the Jupyter Notebook. See this little click? What's that say? Upload. What if I want to download? Let's pick that one. Oh, look, there's a download. So you can upload and download stuff using a nice, pretty tool that you're all familiar with. Okay. This doesn't work yet. The day will come. Oh, and I know it works in Firefox. I've had trouble on Windows getting this to behave itself. File : 123. I guess it just doesn't do Windows. Interesting. Oh, scratch that idea. On Linux, if you go to Linux and type in file : 123, you'll get a primitive file browser in the browser, so you can look at stuff. But you can't upload, can't download, can't copy, can't change, can't delete. It just lets you look at things, okay? Now that works on Windows, but I don't know what the flag is on Windows. Somebody will have to tell me. I don't remember what it is, okay? Okay, that's what I wanted to do so far. Now let's go back to our, let's make sure I'm on the right box now. I want to go to the Jeremy box. And we are going to go to demo and the .s. Turn that off. All right. Now, this is hello world. With comment. Had you type it in, prints. What we're going to do is you're going to take a few of those labs that are in Zybook, and you're going to convert them to this. Okay. We're going to do a few.
Well, it was a good idea that you showed us the website that you used to convert those.
I will walk you through it. Yeah, we're going to see how, we're going to see exactly how this works. Okay. So when we go to assembly language and down here, the labs, and these 11.1 is just basic training. It shows you how to use the lab. And 11.2 is the arithmetic expression. Okay. How it's working. Okay. How many have done this? A few of you. How many have success? Yeah. How many haven't even started it yet? How many haven't even looked? Let's not do until next week or a month later. I'll wait until the day before. If that is your modus operandi in the world of programming, you will never get good. You cannot cram to be good in programming. Just like music or hitting a home run or shooting three-pointers. It takes a lot of time in the woodshed. Okay. So, and I'll show you the solution for this one. Look at that. That's all there is to it. Okay. So let's show you how this works. Here's what we do. And paste it in. And I can enter the simulation. We can step through it. I have to click on enter the simulation first. Then I can step through it. And it's showing you what's happening. Okay. Kind of like that visualized execution. Okay. All right. And if I run it, I go, wait a minute. Why is it not giving me anything? Why is it all zeros? Bingo. Down here, there is the, you have to give it some values, and that's that test-driven stuff. Okay. All right. So if I say submit for grading, it puts in the test, and then boom. So this is what it is. This is how it works. It passed all tests. Well, yeah, I stole the answer. So learning how to add, basically, and then subtract. How do you do that? Here. How do we add an assembler? Wait, let's think about this. Didn't we kind of do something like that where we added 8 to something? And what do we write that in? C. Is there a way to get assembler out of that C? That's what you're going to go do now. Take that C piece of code and add, see what, add two together, compile it to your .s, as in save temps, okay, or save temps, and then look at your assembler and see if you can reverse engineer how to add an assembler, okay, by building out, taking this something. I'll maybe give you another one. Well, we'll start with this one. We'll see how it works. Okay. We'll start with this one. Okay. How do we add? So that's what you'll be playing with, because that's about all the deeper I want to go in gas and assembler, is how to take something and make it do just a tiny bit different, so you're not terrified of what assembler is about. Okay, because you picked up, we've learned about the debugger and the linker cycle and how to look at an object file. Those are all very important job skills. And today I showed you how to move data back and forth. So if you want to set up your own website, you now know how to push data to your website. Okay. All right. I'll give you 10, 15 minutes to work on this, and then we'll be done for the day. Use Google, play, tinker, and see what you can come up with. Okay. And then I'm not going to grade or collect this one. We're just going to work on it. And I'm not going to tell you when we're going to go over it, but I want you to work on it. Don't wait for me to give you the answer. That's not how you learn. Okay. Well, some people learn that way, but they don't remember it. Let's put it that way. Giving you the answer doesn't help you. I have a story that you can tell your kids. I told this to my grandkids and my kids. This is a true story. Beekeeper is taking care of bees. And they live in their little hexagon thing, right? And this baby bee was working his way out. And the young beekeeper, working with his dad, said, I'm going to help this little bee out. And he takes his pencil and he pushes the wax away so the baby bee can get out. He helped the bee. Baby bee gets its wings, flies about 10 feet, falls to the ground dead. And the little kid was a little upset. And the dad says, it's the struggle that makes the bee strong enough to stay alive. There's no shortcut to learning things the right way. There's all the shortcuts, but it sneaks up on you, and eventually you're gonna have to go back and learn it anyway. Okay, so that's a story you can take to your grandkids and kids. When things get hard, it's so hard. Let me tell you a story. Okay, it's all right. So figure it out if you can. Okay, do your best. Have fun. I do need to mention two things. The day before Thanksgiving, or whatever it is, the college here. Where to go? Oh, here it is. The 23rd. I won't be here. Okay. I'm calling in sick, no tell lay or whatever. So I will have an online assignment for you. It'll be really simple. Because it's the day before Thanksgiving, we're not gonna hold. But basically, I'm gonna be out of state 22 to 27. And Justin Armstrong is going to come back on the 28th. And talk to you. So. And I will be sure that this is in Canvas.